Hi! Today we're talking about finding the x-intercepts of a quadratic function that's written in vertex form. X-intercepts are also called roots and zeros. They are the place or places where a parabola crosses the x-axis. There can be no roots if the parabola never touches the x-axis. There can be one root if the vertex of a parabola is right on the x-axis, so it only touches it in one spot. Or more frequently, there are two roots if the parabola crosses the x-axis and then crosses it again the other side. So when you're solving things, you can have no roots, one root, or two roots, and that's determined by what your parabola looks like and how many times it crosses the x-axis. The x-intercepts are also the solution to a quadratic equation that is equal to 0. The reason for that is that when you cross the x-axis, the value of y is 0. When you're on the x-axis, y is 0 because you're not up or down at all. You're exactly on the x-axis. So when y is 0, really you have a quadratic equation that equals 0. So if you have a quadratic equation that equals 0 and you solve it, then you've found your x-intercepts. Okay, let's look at an example where a quadratic function is in vertex form and how to find the x-intercepts or the roots of this. Okay, the first step is to make y into 0. The reason we make y into 0 is we are looking for x-intercepts. X-intercepts are on the x-axis, and on the x-axis, y is 0. So we're going to make y 0 since we're on the x-axis, and rewrite the equation with y as 0. Okay, now we have a quadratic equation that's equal to 0. Solving this will give us the x-intercepts of our quadratic function. So we need to solve this. The next 3 steps are the same as the steps we were using yesterday to solve quadratic equations with parentheses squared. So we isolate the parentheses, square root both sides, and then solve for x. So first, I'm going to add 16 to get the parentheses alone. And I'm going to wind up with 16 equals x plus 11 squared. Next, I'm going to square root both sides to get rid of squared. So I square root both sides. And I'm going to make it plus or minus because I'm going to use the positive and the negative answer. Square root of 16 is 4, so I'm going to be using 4 and negative 4. And then over here, square root and squared cross off. So I have to solve this twice. I have to solve it once with 4 and once with negative 4. So I have 4 equals x plus 11, and negative 4 equals x plus 11. I'm going to solve the 4 first. So I'm going to subtract 11 from both sides. 4 minus 11 is negative 7. So one of my x-intercepts is at negative 7. And then my other one, I'm going to subtract 11 here. My other x-intercept is at negative 15. What this really means is if I was graphing this, my parabola would look something like this, and this would be negative 15, and this would be negative 7. And that's what my parabola would look like, because these are my x-intercepts. Now, remember I said you could have one x-intercept, two x-intercepts, or no x-intercepts. This is an example with two x-intercepts. I wound up with 2 answers, so I have 2 places where it crosses the x-axis. I'm going to show you an example where you would have no x-intercepts. Let's say we had this, y equals x plus 2 squared plus 5. Okay, so this is your problem. I'm just gonna go like that. we're following these same steps. So we're making y into 0. So this is 0 equals the quantity x plus 2 squared plus 5. And then I'm subtracting 5 on both sides to get my parentheses alone. And now I'm at negative 5 equals the quantity x plus 2 squared. This is a problem because nothing squared is going to give you a negative answer. If you ever get your parentheses alone and they equal a negative on the other side, then the answer is no solution because you can't square something and wind up with a negative. So this would be no x-intercepts. This would be a problem where your parabola is entirely above the x-axis. So if you ever get a situation where you have parentheses squared and on the other side you have a negative, there are no x-intercepts and your parabola is either entirely above or it could be entirely below the x-axis. But either way, it doesn't ever touch the x-axis. All right, have a good day, everybody. Email me if you have questions.